Now we are.
Thank you.
Yeah. So population growth is what we'll take a look at. And I just took a minute ago to look up Hermiston population. And right now, the population in Hermiston is about 18,000 people. Let's say that's in 2020. And then looking at some census data back from 2010 to 2020, it appears that Hermiston was growing at about 10% per year. And so if we wanted to make a model for Hermiston's population after 2010, so population model for years after 2020, excuse me. So years after 2020 would be how I'm going to measure time. So 2020 would be year 0, 2021 would be year 1, and so on. Then the population would be starting in 2020 at 18,000 people. We would multiply by 1 plus the growth rate, 10% is 0.1, and then raise to the power t, the number of years that's gone by. And generally with these, that base cleans up. 1 plus 1/10 is 1 1/10, 1.1. So this would be the Hermiston population model. And again, what do these numbers mean? That number right there is my starting population. In 2020, right? That was given. And then the first one is just from start, is the starting amount. It's like 100% of what you started with. The second one here, that's the 1/10. That's that 10% growth rate. Right? We added it on there. So just a reminder about how these things fit together to form an equation. So kind of similar to that last lesson problem, I'm just taking some real numbers I looked up about Hermiston data. It was around, in 2010, the population was about 17,000. So over 10 years, it grew by 1,000 people. And at those base amounts, that's around 10% per year. So we can then make predictions like, you know, what's it going to be in 2030? So I could predict population in 2030, 10 years later, by just plugging into my formula 10 years after 2020, right? 2030 is 10 years later. So what's 18,000 times 1.1 to the power 10, and that's going to give me the 2030 prediction. So let's make that prediction a calculator. So Hermiston has about 18,000 now. They're growing at 10%, and we want to see what happens in 10 years. And this predicts that the population will be, that seems too big. Did I make a mistake in my calculation? All right, that seems too big. So let me just rethink how I came up with that 10%. So in 2010, it was around 16, almost 17,000. In 2019, they were predicting 17, almost 18,000 for the city population. So that is a difference of about 1,000. So if we take 1,000, the absolute change, divide by the base population of 17,000 back in 2010, we get 5% over 10 years. Crude adjustment of that per year would just be divided by 10. 10 years have gone by. Oh, oh man, I totally messed that up before. Okay, so Hermiston's growth rate is not 10%, it's less, it's like 0.5%. Okay. Oh well. I guess we better do this right. So, yeah. All right, I don't know how I messed that up the first time. So I have errors here that we're going to fix. And I think a new page is necessary. So we have Hermiston 2020. That we're estimating to be 18,000 people. And then the recalculated growth rate, let me look at that again. $1,000 divided by 17,000, because 1,000 was the absolute change, divided by the base gives us the relative change. That's over 10 years, so crudely divide by 10. Yeah, that's more reasonable than the other one. Okay, I think this will work better, and I have a way to check it. So I think the growth rate, I'm just going to round that. So yearly growth rates. Is about 0.6% is that new calculation I just made right there. Now as a decimal, right, so that's 0.6%. Remember, percent means divide by 100. So 6/10 divided by 100 is going to be 6 thousandths. So that means my formula for the future population of Hermiston is going to be the starting amount, 18,000, times 1 plus that growth rate, raised to the power t. And again, that t is going to be years after. So pretty much the same as ideas as before, I just had the wrong growth rate there. So years after 2020. So then we can predict the 2030 population by just realizing that is 10 years later after. So then 18,000 times 1.006 to the power 10. I think this will give us a more reasonable answer than before. Make sure you have enough decimals there. 19,000. That seems reasonable. From 2010 to 2020, it went from 17 to 18,000. So it's going to go a little more than that for the next, because we have a next 10 years, because we have a bigger base to work with. So about 19,000 in 2030. That seems better than the 47,000 I calculated earlier. So that's our prediction. Now we could ask, okay, well, when is it going to be? When's Hermiston going to reach, say, 25,000 people? Is that going to happen anytime soon? So we might want to know that. So this right here is approximately 19,110 people. And that would be in the year 2030. So next question is when will the Hermiston population reach 25,000? And again, that's assuming it's going to stay growing at about the same rate. And those rates aren't fixed. They change year to year, decade to decade. So that's a big assumption, but we're going to go with it anyway, because otherwise we really can't do anything. So what I do then is like I did earlier, we just take our equation, set it equal to compare it to 25,000, and then figure out what the time is. And we're just going to review again how to do that with a little bit of algebra. So we've got our 18,000 times 1.006 to the power t. We want to know when is that going to be 25,000. And so we've done this a couple of times now. We first divide by that extra multiple of 18,000. You can try that on a calculator. If the decimal's not too bad, go for it. Otherwise, reduce a little bit or a lot, it's up to you. So I can easily reduce by 1,000 there. That just divides out on the other side. So now I have 1.006 to the t equals 25/18. And my guess is 25/18 might be a messy decimal. It might not be too bad. 1.3 with a whole bunch of 8s. That's not too bad. So you could use a decimal version here if you want. I'm going to stick with the fraction. To get the power down, that's when we have to break in and use logarithms. So then I just kind of sneak a logarithm on this side, sneak a logarithm on that side, and I get to pull the t out. So it's t times the log of 1.006 equals the log of that fraction. And remember, we can't really get rid of the log without a calculator, but log of 1.006 is just a number. I can divide that number to the other side. And that number just has a fancy name. It's just called log of 1.006. Now you can plug it into the calculator and it'll give you a decimal version, but then you have to write down all those decimals. So I think it's easier to just say, hey, that's the answer right there. Now plug it into a calculator rather than do calculator, 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 calculator 4 times and possibly lots of rounding error. So we do that written work and then we just go to the calculator in the end. So what is the log of 25/18? Close the parentheses in the right spot and divide by the other log. I think that looks okay, equals. So I'm getting in about 55 years from now. So 2020, so 2075 is when it's going to get a population of 25,000 if it keeps growing at just a little more than 0.5% per year. So let's check to see if that actually works. So again, I'm guessing I'm going to round that up to 55 years. So my original equation was 18,000 times 1.006 raised to the power, and now I'm saying let's try 55 years in the future, and hopefully we get pretty close to 25,000, and we do. We're within 12 or 13 people. So I think that's close enough. So back here, I'm going to say t is about 55 years. And again, that would be years after 2020. So we think that in 2075, 55 plus 2020, Hermiston population will be about 25,000 people if it keeps growing at the same rate, and I could state the rate, if it keeps growing at 0.6% per year, which is what I started off with, my assumption. That's a reasonable sentence describing that answer. Big thing here, instead of kind of like a guess and check to find out the year, we can use logarithms to nail it down. And if somebody said, you need to be more accurate, what month is it going to happen in? I can figure that out because I have all those decimal places that I can play with. All right, so questions on that. So big things here were given information about like the starting population and the growth rates. Can we then make predictions about what's going to happen in the future for the growth of this city? Yep. And we can do that in a couple of different ways by just plugging in a certain year or finding the year something will happen in.